Let's talk about homeostasis and its relation to human physiology. Homeostasis basically means maintaining a stable internal environment in the face of change. So, a lot of discussion about human physiology is how your body manages the changes that occur inside your body and how things happen outside of your body that changes the state of your body. How does it manage it to keep a constant internal environment? Let's talk about your internal body temperature. We usually refer to at 98.6 degrees Fahrenheit or 37 degrees Celsius as the acceptable body temperature that we consider as normal when you're not sick. But really, that number is an average of a range of numbers that you can get. So when we report, when we talk about a normal body temperature, it's really a range. When we talk about a normal body temperature, really there is an acceptable range of body temperature. So if you were to measure your body temperature throughout the day, it's not always going to be 98.6 degrees, but it's a range that it goes to, and it may change, may go up and down within this range. So this range is the acceptable range that your body accepts. But let's say if that changes, let's say if your body temperature kind of goes up, then your body temperature goes outside of the acceptable range and your body reacts. Or if your body temperature goes below its normal range, then again your body reacts. So there is a range at which your body accepts small changes, but once the value goes outside of what's called the set point, then it starts reacting. And usually the term that is used, and you're going to hear that a lot, is that these limits are called threshold, which you cannot go above or beyond. So that's the limit of acceptance. Now, when we talk about human physiology and how your body reacts to parameters going outside of the acceptable range, there's some terminology that is used to talk about different aspects of that. So continuing with our body temperature example, in this case your body temperature falls, which is called a stimulus. So this is called a stimulus, and that stimulus then goes ahead and sends a signal. Your receptors in you have body temperature receptors that receive that signal. Then those receptors that receive the message that body temperature has fallen send the message to the control center in your brain. There are areas in your brain that their job is to maintain a relatively constant temperature. So the stimulus is received by the receptor, is sensed by the receptor, and the receptor sends the signal to the control center. Then the control center sends a message, gives directions to the effectors. So you may say, well, which are the effectors? Those are the factors that change to fix things. So blood vessels, the thickness of your blood vessels is one of those effectors. Your sweat glands are the effectors. Then you have muscles in your body that start twitching really fast. So your muscles are the effectors. And then these effectors generate a response. And what are these responses? Well, the vessels constrict, the sweat glands stop secreting fluid, your muscles start twitching really fast, involuntary contraction, and generate heat. That's the response, which then warms the body. And then the result of that is that your body retains heat and your body goes back to normal body temperature. Now, what about when the body temperature rises? So again, the stimulus is a rise in body temperature, which is sensed by the receptor, and then the receptor sends a message to the control center, and the control center sends instructions to the effectors. So again, what are the effectors? The effectors are your blood vessels, which dilate. Then let's see, sweat glands again are the effectors. And then what are the responses? The responses are dilation and then secretion of fluid, which is sweat. So therefore, these cause a response which leads to loss of heat to the environment, and then your body goes back to normal temperature.